Hello everyone. In this video, we will cover the concept of what do you mean by symmetric key agreement and how the session key will be generated without using the KDC. In the previous video, we have covered the concept of KDC and how the keys will be generated with the help of this key distribution center. That is nothing but our KDC. But in case of symmetric key agreement, the KDC is not available. Still also we can generate the symmetric key, that is session key, between multiple users. So what do you mean by key agreement? So key agreement is nothing but two or more users, they can jointly contribute the information that is established between a share and symmetric key. So why it is called as a symmetric key? In case of symmetric key, we are creating only one key for encryption as well as decryption. So there is only one key is used for encryption as well as decryption. That's why it is called as symmetric key as well as session key. If both the parties are agree on the same key for exchanging between each other and they are using only one key for encryption as well as decryption, that is called as symmetric key agreement. Now we will see what do you mean by Diffie-Hellman key exchange algorithm. Based on this approach, we are creating a shared secret key without using the concept of KDC. Here KDC is not present. Still also we can create a shared secret key between both the parties, that is Alice and Bob. We have two public numbers, that is value of our P and value of our G. P is nothing but our modulus value and G is nothing but our primitive root value. On the ally side, they have to choose one number, that is X, that is called as private key of Alice. And on the Bob side, they have to also choose the value of Y, that is private key of Bob. Now Alice will have value of X, value of P and value of G. Based on that three values, they have to calculate the value of R1. So R1 is nothing but G raised to X mod P. Once Alice will calculate the value of R1, this value will be sent to the Bob. And in the next step, Bob will calculate G raised to Y, that is primitive root raised to private key of Bob mod P. Based on that formula, they will get the value of R2. So this R1 and R2, it is nothing but public keys for Alice and Bob. R1 is the public key of Alice and R2 is the public key of Bob. After calculating the R1 and R2, R1 value will be sent to the Bob and R2 value will be sent to the Alice. Now Alice will have the value of R1 as well as a value of R2 that is sent by Bob and value of X, that is the private key of Alice. So based on that value, they have to calculate the value of K. So K is nothing but R2 raised to X mod of P. So the K is nothing but your public key of Bob raised to private key of Alice mod P. And on the Bob side, value of K is equal to R1 raised to Y mod of P. So R1 is nothing but public key of Alice raised to private key of Bob, then mod of P. That is nothing but your K. We have another formula for calculating the shared secret key, that is K is equal to G raised to XY mod P. So G raised to XY, it is nothing but primitive root raised to private key of Alice, private key of Bob, mod of P. So P is nothing but our modulus value. And based on that formula also, we can calculate the shared secret key. So this is nothing but our Diffie-Hellman key exchange algorithm. In the next video, we will cover how to solve the example using this approach.